Hello student, I am Dr. Ajay Kumar Sinha. Today I am going to discuss stoichiometry and stoichiometric calculations. The word stoichiometry is derived from the two Greek words stachirion. Stachirion, it means element and metron means measure. Then stoichiometry thus deals with the calculation of masses, sometimes volume of the reactants and the products involved in a chemical reaction. Stoichiometry that came from the word stoicherion, and this is a Greek word and its meaning is a element, and other word metron and its meaning is measure. Measure means we have to find out element. We can determine the element in a balanced chemical equation. Before understanding how to calculate the amounts of reactants required or the products produced in a chemical reaction, let us study what information is available from the balanced chemical equation of a given reaction. Just we are considering one example combustion reaction. Then combustion reaction example like this methane, combustion of methane, CH4 plus 2O2. It gives carbon dioxide plus water, means H2O. Then if you write the reaction in a balanced form, then it will be CH4 plus 2O2 and then arrow sign or equal to, you can write CO2 plus twice H2O. Here all are in gaseous state, means methane gas, already gas is there and it will be in the gaseous form. Oxygen is there, 2O2 means here oxygen gas, that also it is a gas, hence you should write for both, for methane and gas, in bracket you should write a small g, and product side means right side you should write CO2. CO2 means carbon dioxide gas, and this is also gas only, plus 2H2O. Here you should be careful. Here 2H2O, H2O exists in liquid also and vapor form also. Here it is in vapor form. That's why you can write a small g. Then product side also you should write a small g, carbon dioxide in bracket you write a small g, and 2H2O in bracket you write g. Hence balanced equation will be like this: CH2 in bracket you write g, a small g, plus 2O2 in bracket g, and then arrow sign or equal to sign also you can write CO2 in bracket g, means small g means gas, plus 2H2O again in bracket we can write g. This is the, you can say, complete balanced equation. Here methane and dioxygen means O2. O2 we are telling, dioxygen means two atom of oxygen are called reactant. Means left side, what is that? That is called reactant, and right side carbon dioxide and water are formed. Then this right side what are there, they are called reactant, product. As for example, carbon dioxide and water, these are called products, but left side methane and oxygens are there, methane and O2. Then these are called reactant. Then left side substances are called reactants, and right side substances are called product. Now understand the meaning of coefficient. The coefficients 2 for oxygen in balanced equation 2O2 is there. Then the coefficient 2 for O2 and H2O are called stoichiometric coefficients. This is important. The coefficient of oxygen 2O2 is there, and right side product side H2O is formed. 2 is written there, 2H2O. Then these are called actually stoichiometric coefficients. Similarly, the coefficient for methane CH4, only one is there, nothing is written, it means one is there. And CO2 also, nothing is written, means one is there. Then that is considered that CH4, before the CH4 one is written, and before CO2 one is also there. Then these are also called stoichiometric coefficient. Then now you have to understand that this reactant and product, now they are written before reactant and products. Then they represent the number of molecules. This coefficient represents the number of molecules. Also you can tell moles. Three things it represents. Coefficient represent three things. First things, molecules or moles or N means Avogadro number. Three things it measures. Then now I am telling you that this thing, the balanced chemical equation, what it is telling. Thus, according to the above chemical equation, what we have, I have told you that reaction, that methane plus oxygen, it is giving carbon dioxide and water vapor. Then here CH4 is there, only one molecule of CH3 is there, CH4 is there, and two molecule of oxygen is there, and after the reaction it is giving one molecule of CO2 and two molecule of water. Then now I told you that this coefficient represent molecule or mole or N. N means Avogadro number. Three things. Now you know the details. Again, further 4 information you can get from the balanced equation. Then first one is that 1 mole of methane, because only one CH4 is there, nothing is written, it means 1 mole of CH4. It tells about the 1 mole of CH4. And this CH4 reacts with the 2 moles of oxygen, to give 1 mole of carbon dioxide and 2 moles of water, means H2O. This is the first things I told you, that balanced chemical reaction, what I have given example, that tells, that indicates that 1 mole of methane CH4 reacts with 2 moles of oxygen. Why they are reacting? To give the 1 mole of carbon dioxide and 2 moles of H2O. Now, second important point. one molecule of methane reacts with 2 molecules of oxygen to give 1 molecule of CO2 and 2 molecule of H2O. This is the second information. First information I told in terms of mole, and second information same things but in terms of molecules. Now third information I am talking about, it tells about the volume also. It means 22.4 liter of methane reacts with 44.8 liter of oxygen to give 22.4 liter of carbon dioxide and 44.8 liter of H2O vapor. This is the third information you have to understand here. Methane is CH4. Only one mole is there. Then you know that 1 mole means 22.4 liter at STP. Then 1 mole means that 22.4 liter is reacting with 2O2. Then O2 again 22.4 liter at STP. 2 mole is there. 2O2 means 2 mole. Then 22.4 into 2. 44.8 liter means 22.4 liter of methane reacts with 44.8 liter of oxygen. And what products they are giving? Then they are giving CO2. 1 mole of CO2 means 22.4 liter of CO2 and 2 moles of water it is providing. It means again same thing, 22.4 liter into 2 means 44.8 liter of water vapor. Now fourth you can say what it is indicating or telling, that fourth things that understand now in term of gram. Then here CH4 1 mole is there. Then 1 mole means what? How much gram? Then molecular mass. Then CH4 is 16 gram. 12 plus 4 16 gram. Then 16 gram is reacting with 2O2. Then 2O2 means 2 mole. Then 1 mole means molecular mass. That is 32 gram. 1 mole means oxygen, 1 mole means 32 gram. Then here 2 mole is there, hence 64 gram. Means here 16 gram methane reacts with 64 gram oxygen. Then CO2, how much gram it will give? Then CO2, 1 CO2 only means 1 mole. Then 1 mole means CO2 is there. Then 12 C plus 32, 44. It means 44 gram carbon dioxide. It is giving plus twice molecules, 2 moles of H2O. Then H2O, how much gram? 2 mole. 1 mole of H2O means 18 gram. H2O, 2 plus 16, that is the 18 gram. Then 2 moles are forming. Then it means 18 into 2, 36 gram water vapor is forming. Then I have told you that these are the information you are getting from the chemical balanced equation. First, it is telling about the moles or molecule. Second, it is telling about the volume. And third, it is telling about the grams. Then first and second, first mole in the term of mole, second in term of molecules, and third in term of gram, and fourth in term of volume. Then this actually biochemical balanced equation tells these things. Any chemical, any balanced reaction, chemical balanced reaction, their coefficient will tell this type of things. This 4 information you can know very easily, and in solving the numericals, these informations are very useful. Okay. Now on the same concept, now you can easily know that how much reactants are required to give the product, or if you want to know the that you want some product in some special quantity. Now I will give an example. Only from that example all things you can understand. Maybe reaction different, but concept will be the same. As for example, CH4 is there, balanced reaction already written, CH4 plus 2O2 plus CO2 plus twice H2O. Then here suppose CH4 means 16 gram is there. Then now suppose you want carbon dioxide, that is the 44 gram carbon dioxide is required, 44 gram. Then how much methane is required? Then very simple, C 44 gram means 1 mole. 44 gram of carbon dioxide means 1 mole. Then according to the balance reaction, only one CH4 is required, means 16 gram methane is required. Then if methane is 16 gram, then you will get carbon dioxide, how much? 44 gram. Like that way, again question is asked, how much oxygen will be required to get 44 gram of carbon dioxide? Then now again same balanced equation, 2 O2 is required. 2 O2 is required to give 1 CO2, means 44 gram. Then 2 O2 means 32 gram. Then 2 O2 means 64 gram. It means 64 gram oxygen is required for 44 gram oxygen, 44 gram carbon dioxide. Same way, if suppose question is asked, how many grams of you can say oxygen is required for production of 36 gram of water. 36 gram of water. Then here see 2H2O is there, means 2 mole is there. Then 1 mole means 1 mole of water means 18 gram. Then for 2 mole it is 36 gram. Then for the 36 gram, now how much oxygen will be required? Then 64 gram. Then see how this balanced equation is useful in knowing the amount. Same way, in the term of volume also you can calculate how much reactants are required for the any particular products. Easily you can calculate in the term of volume. Already I have discussed CH4 in the terms of volume. 1 mole means 22.4 liter. Oxygen, already I told you that 2 mole, 1 mole means again 22.4 liter, then 2 mole means just
Hello
double.
Student,
Like
I am
that
Dr.A.K. Sinha. Today I am going
CO2,
to discuss
carbon dioxide,
stoichiometry
I told you,
and
22.4
stoichiometric calculations.
And water vapor.
The word
That is
stoichiometry is derived from the
22.4 liter
two Greek words,
That means all information,
stachirion.
how much reactants are required to get
it
a
means
particular
element
product from,
and
from the
metron
easily you
means
can know.
measure. Then
Okay, now today I
stoichiometry
am
thus
stopping only here, and again
deals
we will
with the
discuss
calculation
in the next
of
lecture.
masses,
Thank you.
sometimes volume of the reactants and the products involved in a chemical reaction. Stoichiometry, that came from the word stoicherion, and this is a Greek word, and its meaning is a element, and other word metron, and its meaning is measure. Measure means we have to find out element. We can determine the element in a balanced chemical equation. Before understanding how to calculate the amounts of reactants required or the products produced